I am Alessio.
Hi, I am Marco.
We are both Italian and we study chemistry at the university, and this is our project.
New dyeing and extraction process with wastewater use. In our project, we focus on the design of a dyeing process and extraction of indigo with water savings and use of machine learning model for wastewater reduction and prediction. So the estimated annual freshwater consumption in Europe is 600 million cubic meter. On average, 19% of the water input in textile finishing operation must be treated. Only in Europe, 108 million tons of wastewater is produced per year and 36 million tons of chemicals and auxiliaries must be removed from textile wastewater. And so, moreover, in the face of intense global competition, European textile companies have increasingly turned to research and innovation that can ensure sustainable competitiveness. So, high water consumption and poor controls have led us to develop a method that allows in a sustainable way to limit the use of water, increase controls with low-cost systems, and associated with a method of production and extraction of natural pigments. The aim of our study is mainly concerned to develop a scalable model for the management of water consumption in small-medium enterprise plants for weaving and dyeing, thus reducing wastewater output. And the secondary aim includes the development of an optimized water management plant for the extraction of natural pigments from plants grown via aeroponics, with the 95% of water savings.
Here there are 4 steps that represent our project and what we researched and did. In the first steps, it's about the water footprint in the dyeing process and the extraction of pigments. We made an analysis of the water used in small and medium enterprises. In particular, we studied the water footprint in pre-treatment, dyeing and the rinsing process. We studied the pollutant load in the water leaving the plants. The second step is about the cultivation and extraction process of indigo. We designed the extraction of indigo pigment from aeroponic cultivation and reduction of pollutant load by 90%, reusing the treated water. The third step is about the dyeing process with water save. In particular, we design a dyeing process with natural pigment that we can extract. In the last step, using an artificial intelligence model, we plan to reduce the water footprint and manage the wastewater treatment. First, we made a research on the monitoring parameters of water footprint and pollutant load in wastewater treatment, and with the implementation of a machine learning model, we predict the pollutant load. Here there is the illustration of our innovation. The process design shown can be divided into 3 parts: the cultivation of plants that produce natural pigment, the extraction of pigment, and the dyeing process. The pigment extraction is carried out with fresh water by aeroponic method. It allows the 95% of water saving. In the extraction process, as shown in the diagram, water is recovered during the washing of leaves and roots, and during the final extraction of pigment. The process involves recovering biomass that can be used in agriculture. There, the reclaimed water is treated through a low-cost and verified system for water reuse. It's applied in Europe and provided by the Department of Mechanical Engineering from the University of Maribor in Slovenia. It consists of ultrafiltration, nanofiltration, a membrane bioreactor, and an advanced oxidation process. When the pigment is extracted, it can be used in the dyeing process. Here the water is recovered both in the dyeing process and in the subsequent washing process. Here the water is recovered both in the dyeing process and in the subsequent washing process, which is carried out with fresh water and industrial soaps. The design provides the confluence of the water resulting from those two processes in a filtering system with active carbons. The treated water exiting the filter is then sorted, part of which returns into the invert of the pre-treatment process, and the second arrived at the water collector tank of the pigment extraction system.